Welcome back to Learning with me, Miss Killen, here at MPB. We are in our Unit 2 equations. So we're on Lesson 2, which is properties used while solving true equations. We're looking at A-REI.1. I can follow precise steps to solve one variable equations. So let's go ahead and dive right on in. Equivalent. Now, when we talk about math, we're talking about Algebra 1, we're talking about geometry, Algebra 2, pre-cal. Does not matter what level of mathematics that we're looking at, we are going to have to worry about the word equivalent. Equivalent means the same thing as equal, the same. You will see this in multiple problems. You will see this in multiple units and also along the way up to college math. So I want us to make sure that we're getting this equivalent word down. So here we go. Equivalent, having the same value or produce the same solution for all values of the variables. So what we're going to do is we're going to look at the beginning examples of properties we use to write and solve equations. So let's go ahead and look at this middle box. It says 4 plus 6 equals 10. Then I have 4 plus 6 minus 6 equals 10 minus 6. So what did I do from when I went to the left to the right? What extra step am I showing? Yes, I'm doing subtraction. All right, so let's look at the next one. I have y minus 4 equals 9. Then I have y minus 4 plus 4 equals 9 plus 4. So what's my extra step that I did going from my left side to my right? Exactly right. I am adding. So let's look at the next one. 3 times 5 equals 15. Then I have 3 times 5 divided by 3 equals 15 divided by 3. What is my extra step that I did on the right? Exactly right. I'm doing division. So then the last one says n divided by 3 equals 4. So then I have 3 times n divided by 3 equals 3 times 4. So what's that extra step that I'm doing? I'm multiplying. All right. If the two equations are equivalent, you can give a descriptive phrase of the operation in the second equation. And that's what we did. We subtracted. That's describing the action we did. We added. That's describing the action that we did on the right. Division and multiplication. These are different operations we're doing, and with these different operations, there are properties of them. So it says we have 4 properties of equality. As you can see, it means it is equal. So our equality is the same thing as equal. Our equivalent is also saying same thing or equal. So let's look at these properties. The first property that we have that you'll either want to put in some notes or on your properties notes page, it says adding, addition, or subtraction property of equality. If A equals B, then A plus C equals B plus C, and A minus C equals B minus C. If you add the same number to both sides of an equation, then the equation stays true. If you subtract the same number to both sides, the equation stays true. So let's do a couple of examples just to make sure we're seeing this. So if I had this equation and I want to get x by itself, but I have to keep this equation equal at all times. That means whatever I do to one side of my equation, I have to do to the other side. Think about it like this. If you have a brand new vehicle and you're going to go out into the yard and wash it, are you just going to wash the passenger side? No, you're going to wash both sides. Or if I'm putting on makeup, am I just going to put makeup on the right side of my face? No, I'm going to put makeup on both sides of my face. So when I'm thinking about this equation, I'm thinking about those two instances. I'm doing something to both sides, and I have to do the same thing to both sides. So here, if I add the 3 to both sides, I keep it equal. I have x and 10. So it is equal, and I have found out what my variable equals. So let's look at another one. So if I have x plus 4, and I think I'm going to do this one in a different color, just so I have different colors. I have x plus 4 equals 9. Now, I want to make sure that I keep this equation equal. Well, Ms. Killen, why can't I just add 4 to both sides? Good question. Let's see what happens. So if I added 4 to both sides, I have x plus 8 equals 13. So I don't have the equivalent equations that I did. So that's why when I have an addition problem, I must do the opposite, which is subtraction. So I'm equal on both sides. I have the same thing on both sides. I'm doing the exact same thing. I'm washing the car on both sides. I'm putting makeup on both sides of my face. So then I have x equals 5. So what I want us to see is y. So right here, I'm going to tell you to solve a subtraction problem, I'm going to do what I call op-op. Now, when I taught middle school, they would always remember this op-op, opposite operation. Anytime that I'm solving these different problems, I always do opposite operation to get everything on one side so they are equal. If I'm subtracting on one side, I'm subtracting on the other side. If I'm adding on one side, I'm going to add on the other side. I have to do the opposite operation on both sides. So I'm doing opposite operation. So to solve the subtraction problem, you do opposite operation to isolate your variable. Now, Ms. Killen, what in the world does isolate mean? So everybody remembers COVID. Everybody remembered when someone got sick, they had to isolate, self-isolate, meaning they had to get by themselves. So when I isolate my variable, what am I doing? I'm getting it by itself. And that's what I did right here. I did opposite operation. I had subtraction and I did addition on both sides. And I isolated my variable. So that's what I do when I solve a subtraction problem. Well, Ms. Killen, what about that addition problem you got down there? Good question. So to solve an addition problem, I'm still going to do my opposite operation. And since I had an addition problem, I subtracted, which is the opposite operation, to isolate my variable. So it's the same concept no matter what type of problem I have. If I'm subtracting in the problem, I'm going to add, which is the opposite operation, to get my variable, x, whatever it is, by itself. If I have an addition problem, I'm doing the opposite operation, which would be subtraction, on both sides to isolate, get by itself, my variable. So these are very key words that we need to make sure we're understanding. All right, so here we go. Our next property that we're looking at is multiplication and division property of equality. If A equals B, then A times C equals B times C, and A divided by C would equal B divided by C. If you multiply both sides of an equation by the same non-zero number, we've heard that before, the equation remains true and equal. If you divide both sides of an equation by the same non-zero number, the equation remains true. So let's take what we've learned from this property, how we're isolating, how we're keeping our equations equal, and let's do a couple problems. So here we go. The first one I want to look at is x divided by 3 equals 5. So then it's a division problem, so I'm going to use my opposite operation. And since it's division, the opposite operation is going to be multiplication. So I'm going to multiply by my 3 on both sides. So I am multiplying by 3 on both sides. Now, Ms. Killen, I have a whole number 3 multiplied by a fraction. So how do I make a whole number a fraction? We put a 1 under it. So what do I know about multiplying by fractions? I multiply straight across. 3x over 3. The 3's cancel out, or they reduce to a 1. So I'm left with x. 5 times 3 is 15. Now, as we progress in this course, I'm not going to do all this math. What I'm going to do is multiply my fraction and then just x out or cancel out what I'm multiplying by and leave my variable. All right? So you'll see something like this. So then let's look at this problem. Let me get a different color because I like color. So I have 4x equals 20. Now what kind of problem is this? It's multiplication. So then if I have multiplication, how am I going to get that x isolated? I'm going to do opposite operation, which is division. Absolutely. So I'm going to divide by 4 and have my x left. And then I'm going to divide by 4 on both sides, and I have a 5 left. I've isolated both of my variables. I've done opposite operation on both sides to keep my equations equal. You have to keep it equal. It's kind of like this balance. It has to stay equal. One side can't be heavier than the other. You have to keep it equal. It has to stay equal. All right? So let's look on. It says, let's do some practice. Isolate the variable. There's that word again. Tell the property you used. Okay, so let's look at number 1. It's a division property, or excuse me, it's a division problem. So if it's a division problem, what property would I use? Exactly right, multiplication. So let me go ahead and get a different color. Let's use red. So since I'm dividing by 4, I'm going to multiply by 4 and have my x left. If I do it to one side of the equation, I must do it to the other side, and so my x equals 24, and I used multiplication property. Good job. Let's look at number 2. All right, so number 2 says t minus 7 equals 12. I have a subtraction problem, therefore I'm going to use what property? Addition. Because I'm going to add 7 to both sides. So my t equals what? 19. And I used my addition property. All right, let's look at number 3. Y divided by 2 equals 9. So what property am I going to use for a division? Yes, I'm going to use multiplication. So I'm going to multiply by 2 on both sides. So my y equals 18. And then number 4, I have an addition problem. So what property would I use for an addition problem? Subtraction property. So I'm going to subtract from both sides. M equals 11. So I've seen what the problems are. I've seen what the different properties are. Depending on what I have to do, depends on which property I have to use. So let's look. My next property is the distributive property. Now, I'm going to give you a little scenario about this distributive property. Okay, think I'm a chip company, okay? And you and your table partner, or you and the people around you, are different stores. I leave my company's warehouse with a whole truckload of chips, and I take my chips to each one of your stores and distribute them. Okay, I'm giving you my chips, so now you have your store with my chips. The next person has their store with my chips. I have distributed my chips to everyone. Same thing with the distributive property. So let's look at this. This property lets us multiply a number or variable outside of parentheses by everything inside these parentheses. So A times B plus C would equal AB plus BC. Ms. Killen has to have things to help her remember. So what she does is draw indicators, which are going to be my arrows. What that does, it helps me stay on track what I'm multiplying and what I'm multiplying it to. So let's look at these two problems. 3 times 5 plus 7. Ms. Killen is going to use her indicators, and the more we get into this course, you will still see me use these indicators. So 3 times 5, and I'm also distributing it to 7. So 3 times 5 is 15 plus 3 times 7 is 21. When I add those together, I get 36. So now I'm going to use the distributive property on the bottom one. I'm going to draw my indicators. Ooh, that was not a very good drawn indicator. I'm going to draw my indicators just to keep me on track. 3 times x is 3x. 3 times 6 is 18. And that's as far as I can go. Why is it as far as I can go? Because I do not know what the value of that variable is. So I just have to leave it as an expression. Good job. My fourth and final property that we're going to do today is the commutative property. Now, this is the way that I explain commutative. Think about your community. Okay, so I have a blue house here, I have a yellow house here, and I have a red house here. The red family wants to move into the blue family's house. So the blue family moves into the yellow family's house, and the yellow family moves into the red family. Ms. Killen, what are you talking about? They moved places, but they're still in the same community. So when I think of the commutative property, I'm still in the same problem or community. I just moved houses. So let's look at this. If you change the order of the number or variables in an addition or multiplication problem, then the results will be the same. A plus B equals B plus A, or A times B equals B times A. It's important, extremely important to know that the commutative property does not. It what? It does not. It what does not work for subtraction and division. You have to remember this. This is worthy to put in your notes in red, marker, highlighter, put your hand on it and whatever. Always remember, it matters how you put those subtraction problems and those division problems. So let's go over here and look at addition and multiplication. Then we're going to come back to this subtraction and division. So if I used 3 plus 4 equals 4 plus 3. Well, obviously 3 plus 4 is 7. 4 plus 3 is 7. So it doesn't matter the way they are or which house they're in. They're still in the same community and they still equal 7. So let's see if it's the same for multiplication. So let's use 3 times 4 equals 4 times 3. Well, we know 3 times 4 is 12. 4 times 3 is 12. So they equal. Now, Ms. Killen, let's go back to this important thing that you made such a big fuss about. Okay, when I have a subtraction problem, I'm taking something away. Something's gone. Poof, it's just left. So if I have 5 minus 2, I get what? I get 3. If I have 2 minus 5, I get a negative 3. It does not equal. You cannot have $3 and have a negative $3, meaning you owe somebody. It just doesn't work like that. So let's look at the division problem. 10 divided by 2 is 5. When I have 2 divided by 10, I get a fraction, and that fraction equals 1/5. So instead of having 5 slices of pizza, you're saying 5 slices of pizza is the same thing as having 1/5 of a slice. That's a teeny tiny slice. I hope you're not hungry. So it matters in subtraction and division. It does not in multiplication and addition. All right, so let's look. So it's time for you to master. So we've learned all these properties. We have taken notes on them. We've done examples on them, and we have done examples of practice. So now it's your time to show me what you've learned. So what I want you to do is pause the video, you and your table partner, go ahead and work these problems, and then come back to me and let's see what we got. All right, so here we go. Look at your work, look at y'all's work if you worked with your table partner, and see if I get the same thing you do. So here we are. 7 plus y equals y plus 7. I'm going to say this is the commutative property, and I'm just going to put that. Y divided by 4 equals 10. So since I have a division problem, I'm going to use my multiplication property. 6 times 3x plus 4. I have a parentheses. That's really important. So I know I am distributing. So I have the distributive property. I have 12 plus x equals 17. So I have an addition problem. So I'm going to have to use my subtraction property. Then I have 17x equals 85. It's a multiplication problem, so I'm going to have to use my division property. Look at your work, look at my work, make sure I did it right, make sure you did it right. If there's a difference, you and your table partner or you and your class, y'all talk about it. See what was different. Go back and look at those properties. Always make sure that you can have your notes there to double check yourself. Things we don't want to forget. What equivalent means. It's the same thing. You have the same properties. You are keeping the equation equal. You are saying it's the same thing. All the values are the same. What does equality mean? It means it equals. How to isolate the variables. We're using the what? Opposite operation. What our 4 properties are. We have addition and subtraction properties, multiplication and division properties, the distributive property, and the commutative property, and how we work each one of those. You'll remember the distributive property, I distributed the chips. With the commutative property, people just changed houses, but they're in the same community. Good job. I am so glad that you came to learn here with us at MPB. I'm having a great time with these equations. I am Miss Killen. I want you to have a great day.